It's a distinct pleasure to be among with you because I am given this very significant opportunity to discuss with Professor Leonidas Platanias, who is one of the most noteworthy doctors in research on cancer, which of course leads to the cost of a host of lives. In 2022, Mr. Platanias is Professor of Oncology. He is Director of the Robert H. Lurie Comprehensive Cancer Center in Chicago and Associate Vice President for Cancer Program in the Northwestern University. Welcome. Thank you very much. And before we start, I should like to thank Mr. Spirtunias and the American Hellenic Chamber. And it's a great pleasure for being here. No, the pleasure is all ours, and I would like to start straight away. Were you one of those children who was dreaming from the beginning to get into medicine, and how did oncology come as a specialty for you? Well, when I was in middle school, it did cross my mind back then, and I, made it into medical school. When I first started studying medicine, I wanted to be a cardiologist. And then my father got leukemia, and there weren't many drugs at the time, which made me think that cancer may be more difficult to tackle, more important, more significant, and I switched my major and I got into oncology. Now, how was that as an experience? Because you had your father ill with leukemia. Did it make you see things differently, science differently, life itself maybe? Oh, but of course, yes. Life differently, the health system, I saw that differently as well. And I was in Patras at the time, at the university, which was endowed with many professors who had studied in the States and came back to teach at the university, which led me to want to go to the United States, study and do research. So everything influenced my decision significantly. So when you did go stateside, did you see things the way you expected them to be, or what made you remain at the United States? When I first went to the United States of America, I first went for research at the NIH, the National Institute for Health in Washington, District of in Washington in general. So you had to do through a lot of hoops to do clinical research and clinical medicine. But that being said, it was also tremendously interesting. That was the time of AIDS, and research leapt forward at the NIH. Things were very impressive. So I was doing research at a very good department that had to do with bone marrow. And I decided that I didn't want to come back. I wanted to stay there, do my research, and have a career stateside. Now, from what you have researched along with your colleagues all these years you've been in the United States, what was the most difficult thing? But when you finally achieved the goal, it was something that was really great, really satisfactory, really innovative in cancer research. Well, you see, first of all, I did my residency in New York, and then I moved to Chicago. I was at the University of Chicago at the time. I was doing my sub-residency in hematology, oncology, and research there, and it was on interferons. Now, interferons are substances of the immune system, and they have to do, at the moment, with how our immune system responds to cancer. So when I had my own group, it was an awfully competitive thing, and I was quite young because, you see, there was a huge breakthrough by some very important researchers at the time. They had discovered a series of biochemical changes that were indeed very important in that respect. So what I had to do was compete against a very powerful, a very strong group of scientists. And all of a sudden, I started doing things that were, in fact, very risky research-wise. And it went against the status quo. So you were on your own and you started taking a risk to do something that had not been done until that time? Yes, quite right. And At the time, there was a very powerful status quo because it was a huge discovery. It was in the right direction, but it wasn't the whole story, you see. It was just a small part, but everyone thought that that was it. So what we did, my team and I mean, is that we believe that that wasn't the whole story. So we did research, we did things, and it was tough at the time to change this whole mentality, mindset, and status quo, but we were in the right direction. And this changed a whole lot of things in this field. Truth be told, research is very important, but until such time as you meet your goal, you suffer many defeats and disappointments. How does that affect the psyche and the psychology of a scientist? Does that make you more stubborn, stick your heels in and dig in your heels and move forwards, or do you get upset? I mean, scientists are human after all. Well, there are two scenarios. One of them is one to get disappointed and stop and leave, and many people do so. They join a private firm, for instance. The other route is to persevere and insist. What I've always done is that I didn't care about rejections. I kept on insisting and going back, and I think that that's the way to deal with such an adversity. Let's move on now to treatments. Of late, we've been hearing about a lot of interesting and important finds, not just at the level of clinical research, but everyday clinical practice regarding immunotherapy, which is, applicable in many forms of cancer. There is also a debate talking about that it may even replace chemotherapy. So could we please have a comment on immunotherapy and, is it at the moment, research-wise, something else innovative in the pipeline, which we will see in the next few years come into clinical practice, which will help our fellow people with cancer? Well, yes. Human immune system is extremely powerful. It has the capability to stop cancer, and it does so under normal circumstances. We all have cancer cells every day that are halted by the immune system, and we don't suffer from cancer. Does this pertain to a healthy organism? Yes, healthy. So every organism, apart from the healthy cells, does it contain some sick cells? Yes, some go astray, they become anomalous, but they're insignificant, they're a very small number, and so our immune system is in a position to stop them. So when cancer does, in fact, present itself, and the immune system is unable to stop it, then the way to attack cancer is to stimulate the immune system. And these treatments, and this is something we've known for 100 years, there is something there that happens, but there was very, very small, minute indications that didn't allow us how to use it. So 15 years ago, if you asked me, I would have said that the immune system is not something we can stimulate with good treatments. And it was a tremendous change, what we did. And it was the 2018 Nobel Prize. His name was Gene Mallinson, an American, and a Japanese who discovered what we call the checkpoints. What happens? It's because our system does not want the immune system to be always aggressive. There are some breaks. And these breaks were discovered by the recipients of the Nobel Prize of 2018, James Allison and Tasuku Honjo. There were drugs created that removed those breaks and allowed the immune system to attack the cancer tumors. And there was a lot of response and people who used to die survived. But it's still a small percentage, which means that we don't exactly know how to use it yet. I would call it a brute force attack that you unleash against cancer. But you see, it's not easily targeted. Okay, you can't focus it easily. So there's a lot to be done, a lot to be discovered, but we've had a lot of progress in this field. Now, please share with us your opinion on the following. Truth be told, research is moving forward very, very fast in the field of cancer. There are many patients who overcome the disease. There are many forms of the disease that, when detected early, we have full cure. Unfortunately, this does not hold water for all forms of the disease, and there are people who still lose the battle. What I would like to ask is this. All these years that you've been researching this disease, have you discovered a specific feature, characteristic, as it were, which holds or hinders the results of the treatment, or something that leads to the reproduction of cancer cells and makes it impossible to stop the cancer cascade? What is it that makes cancer so difficult to eradicate for all these years that we have funding for research, and it's research the world over? That is a very good question. First of all, it's not just a cancer. We have various forms of cancer at various levels. And there are different molecular mutations that make cancer more or less aggressive. There are several features and characteristics that one can monitor to see whether a cancer will evolve into an aggressive one or whether it will be a more moderate one. So do we know beforehand that certain forms of cancer unfortunately will not have a good outcome and are more difficult forms? What cancers are they? On what organs? Are they hematological cancers? On solid tumors? Well, both. In solid tumors, now, the most difficult ones are brain cancer and pancreatic cancer. Both these cancers are, immunotherapy is ineffective against them. Whereas in lung cancer, which was always considered as very deadly, we have some groups of people with lung cancer, various subgroups, that actually respond well to immunotherapy. What I'm trying to say is that we know some things, and there are other things that we don't know. We don't really know the reasons why pancreatic cancer and brain cancer are so much worse and so much more difficult than the others. So this is still open for research, isn't it? Indeed it is. My department performs research on these two particular diseases and on leukemias. And we do have some indications as to what exactly may cause this resistance on behalf of the cancer, but it's very early. And this is not just a single thing. There's a lot that we don't know. Now, do you know, sir, what happens to the people, to the people, even we as journalists, we read about new research findings that say this happened on guinea pigs and they achieved a cure, that percent in this form of cancer. When this publication goes live, do you see something of the like in the United States? There's a craving, a desire in patients to have this treatment. And we can't really realize that it's something at a phase that it has many opportunities that will not make it to clinical trials on humans. Or from the moment that research actually is performed, everything goes well, there's a long number of years until a drug is developed for wide use. Is this a global concern? Well, I would compare this to fireworks by the press, because it draws attention, and journalists, want to promote things and want to use it as clickbait, as it were. Now, there is always this hope, this stress, this concern, but when it's very early, especially when we're talking about guinea pigs, lab rats, it's very difficult to say whether something will be effective in humans. There are many drugs that work on lab rats, and when you try them on people, they don't work at all. So we're still at the very early stages to celebrate or anything, and unfortunately people who read these things don't know what to do, and they need to be more reserved. So I would advise caution. Are you optimistic that at some point in the near future, ideally, we will be able to take steps to handle difficult forms of cancer, or to, just maintain them as chronic diseases if we can't rid ourselves from it? Now, I must say that very interesting steps and important steps have been made forward regarding immunotherapy. It's a huge hope. And there's a lot of other things that can be done, but there is the whole field there, and that there are other sciences that have developed very, very fast, like big data that we talked about yesterday, or bioinformatics or bioengineering. Nanotechnology, artificial intelligence, everything is utilized in cancer research, which makes things leap forward faster. There's faster progress, which is, I am confident that we will have new results and new treatments very, very fast that will work. But when we're talking about totally eradicating cancer, this is a totally different ballgame, and I don't think that medicine is anywhere near achieving this, but we're very close to progress that will save people, an increasing a number of people, fast. Right, so you said that you're doing research on leukemia, pancreatic cancer, and brain cancer. Would you explain in layman's terms what exactly you're researching? Well, what we do is two things. Now, you see, cells metabolize substances, and there is something that is called mRNA translation. It's a step before the gene transcription. What we're trying to do is using drugs to break cancer cell function. The other very important thing we're doing has to do with immunotherapy. And what we believe is that the drugs we have now, the checkpoint inhibitors that are everywhere, you can see them on television and everywhere. These, in essence, are antibodies that inhibit the checkpoints I mentioned earlier. They are located on the surface of cancer cells, but they only work at a 10 or 20%. There are differences between the cancers. What we believe is that similar proteins exist that are not on the surface, and it's much more difficult to attack. So we believe that they exist, and we try to create drugs to counter checkpoints within the cell. This takes more time, but I believe that at some point this may be of significant help. And well, we only have a few minutes at our disposal. I would like to ask, what is cancer for you? Is it, for many people, are the enemy, that bloody disease? They even avoid mentioning the word. And what is it to you? Because you had that nasty experience in your own family. Now, truth be told, it's a disease that is very difficult. It's probably the worst disease that humanity has ever had to deal with, and it dates back millennia. So we need to, well, declare from the outset that it's a very difficult disease, but it will not go away if we simply do nothing but look at it. Now, what's good is that science is evolving very fast. We have new drugs, and an increasing number of people are being saved. So is it a challenge for you? Yes, it's a challenge for everyone, for humanity. And we saw the case with COVID, when humanity stood together and decided that we need to come up with a vaccine very, very fast. It happened. We haven't had that with cancer. Okay, we have different teams working independently, and they don't work together. Is it that? No, it's not that much. It's investment. Now, in COVID, we had a huge investment both in the public and the private sector. In cancer, we don't have that much of an investment. So is it financial reasons? Yes, I would say so. So, Professor, what is your goal for the next 5 to 10 years, or even your own personal wager, if you have one? Well, I wouldn't call it a wager, but what we're constantly trying to do is certain things that we think will help, and we're trying, we're striving, we're attempting to develop them fast. That's all. How fast you can get there. Now, in our Cancer Institute, apart from my own personal team, we have a host of other teams, and I'm trying to help all of these teams at the same time. It's a big thing that we're doing. And I'll have to say, the big challenge is how fast you can get there, because we know that at one point or another there will be a cancer treatment that will break out and save people. The problem is when, because in the meantime people are dying. So the faster we can mobilize ourselves and get there, the more people will live longer. One last thing, I see that we can still have a couple of minutes. Have you ever given it any thought of leaving Chicago? Well, you have all these research projects running. I mean, I don't think it's feasible, but has the Greek state invited you for a collaboration in the field of cancer? Is it something that you have in the back burner to come back at some point in time? Well, we always want to collaborate. Science wants collaboration, and I am Greek. But coming back to Greece, well, this would have happened a great number of years ago. There were chances and opportunities in the past when I could have done it, but I believe that in the US, science was far more advanced, so I decided to remain there. But things have been progressing in Greece, and progress is impressive in Greece, and it's a huge difference between when I last saw things and today. And there's a lot of people who are coming back from the States and they work in Greece. Thank you so very much for this distinct honor. I hope that in one of our next meetings we will have something more tangible and something great to help patients with cancer. Thank you very much. It was a great pleasure, and I want to thank the AmCham and everyone here today who were with us. Thank you very much, one and all.